Question 2 asks us to test the significance of the correlation coefficient R at alpha equals 0.05 for the data below. Here's our data, X values, Y values. We want to test the significance of the correlation coefficient. So when we say that, that means we want to determine how significant the relationship between, we want to test how significant the relationship is between these two variables. Remember, the correlation coefficient R tells us about the strength of that linear relationship between these two variables. So to test this, it's a hypothesis test, right? So if you remember from the last set of videos, if we have a general procedure for solving hypothesis testing problems, and this is going to be the same for all of the videos in this topic as well, right? There are these 5 steps for solving hypothesis testing problems. State the hypotheses and identify the claim. Find the critical values from the tables below. Compute your test value, and then make your decision to reject or not reject the null hypothesis, and then summarize it back in the real world terms. So that's what we're going to do. That's exactly what we're going to do here. First, let's state the hypotheses. So for these testing the significance of a correlation coefficient problem, we'll use the sample correlation coefficient, which is called P. Let's write something a little different. So the null hypothesis will say that the sample correlation coefficient is 0. That means there's no relationship between these two variables. There's no significant relation. There's no significance between these two variables. The alternative hypothesis says that the sample correlation coefficient is not 0, which means there's some relationship. It could be a positive one, it could be a negative one, but there's some relationship. And we don't need to identify the claim because we're testing the significance, right? So we don't need to identify a claim for these. So this is step 1, right? So I'll write step 1. State the hypotheses and identify the claim. Step 2, what does it say step 2 is? Find the critical values from the appropriate table. Okay, so how do we find the critical values here? Well, let's scroll back to this chapter 10. Chapter 10, yeah. T-test for a correlation coefficient. Here's the T to calculate the T value, which is going to be our test value, right? But then here we're also told the degrees of freedom n-2. That's important. So the degrees of freedom are n-2. Now here, n, how many pairs? 1, 2, 3, 4, 5 pairs. So 5 minus 3. The degrees of freedom are 2. There's 2 degrees of freedom here. And we're testing at alpha equals 0.05. This is a t-test, right? It says it back in the formula. Two-tailed, right? This is a t-test. 2 degrees of freedom. Alpha equals 0.05. Two-tailed. Let's scroll down to the t-test. T-distribution table. 2 tails, alpha equal 0.05. 2 degrees of freedom. Was it 2 degrees of freedom? See what I did? See what I did? I know you're going to tell me in the comments. I know you will. 5 minus 2 is 3. I got a little ahead of myself, right? So there's 3 degrees of freedom. Making sure you're on your toes. So 3 degrees of freedom, 0.05, 2 tails. So 3.182. So critical value, 3.182. Is that what it was? Let me just look again. 3.182. Yes, 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 yes. Okay, so if I was to draw that relationship, right, I can show that. Here's what we're talking about. So 3.182 is my critical value. So I've got negative 3.182, positive 3.182. Classic hypothesis testing stuff, right? 2 tails. So I've got 2 rejection regions. Step 3, I'm going to calculate that test value. If that test value is less than negative 3.182 or greater than 3.182. If it falls in either of these regions, we're going to reject the null hypothesis. We're going to reject that the significance is 0, that the correlation coefficient is 0. We're going to reject that. Yes, yes. Yes, yes. Yes, yes. Okay. So, making sure I'm still recording. Okay, good, good, good. So, step 3. Step 3 of the process. We have it. Compute the test value. So let's go back. T-test. T equals R times the square root of n minus 2 over 1 minus r squared. Degrees of freedom over 1 minus r squared. Okay. So T equals R times the square root of n minus 2 over 1 minus r squared. Now, what does that mean? We need to find r. And we're not doing it like I showed in number 1. We're going to use the calculator for that. Okay? Because I don't want to add that much to this problem. So now I'll go to stat, edit, because I'm going to put some more values in here. And if there's data in there, you hit second and plus for memory. 4 is clear all list. Hit enter, so you get all that data out of there that was there before. So stat, edit, let's put these values in. 43, 51, 56, 66, 73. X values. Y values. 98, 103, 108, 113, 118. Make sure I got them. 43, 51, 56, 66. Okay. 98, 103, 108. Yes, yes, yes. Then I go to stat. Calculate. I hope diagnostics are on. 4. And they still are. Perfect. And look, I even get r squared as a bonus. R squared is just r times r, right? But I have it there so I can use it. So r, always use those 3 decimal places, right? So r is 0.996. So t equals 0.996 times the square root of n minus 2, which is 3. We calculated that. Over 1 minus r squared we have there as 0.992. So I'm going to just put this in our trusty calculator and calculate this. So I've got 0.996 times, times the square root of 3 divided by parentheses 1 minus 0.9992. Since I have multiple terms in that denominator, I'm going to group them with parentheses and go that way. So T is 19.287. Oh gosh, I dropped my pen. Where'd it go? I don't see it. There it is. Rolled under my desk. So what's T again? 19.287. 19.287. Okay, so that's our test value. Step 4. Make a decision. This test value here, 19.287, is definitely bigger than 3.18. It's definitely bigger, right? So it's in this rejection region. So the decision is reject the null hypothesis. And step 5, for putting this in real world terms, we can say there's enough evidence to say that there is a significant relationship between these 2 variables. I'll just say that I don't want to write it. Right? There's enough evidence to say, to support the claim, to support, we didn't say anything about a claim, but to support there's a significant relationship between these 2 variables, that the significance is not 0.